Welcome to the fourth lesson in Chapter 5 of the Pearson video lecture series. This lesson discusses basic triangle properties and inequalities. Let's start with what we mean by inequality. If there's an inequality with the sides of a triangle, then the triangle won't close. That's going to be important later. Theorem 9 sets up the first property of triangles. It says the largest angle is across from the longest side, and the smallest angle is across from the shortest side. That means that if angle B is bigger than angle A, then side B is going to be longer than side A. In our first example, the sides of a triangular garden plot are given. Using the property from Theorem 5.9, write the angles from smallest to largest. Since EF is the smallest side, then angle D is going to be the smallest angle. F is across from the next smallest side, so angle F is going to be the one in the middle. And since angle E is across from the longest side, then angle E is going to be the largest angle. The second property in Theorem 5.10 is the converse of the first property. It says the longest side is across from the largest angle, and the shortest side is across from the smallest angle. So if side B is longer than side A, then angle B is going to be bigger than angle A. Given triangle MLK, we want to find the missing angle and write the sides from smallest to largest. To find the missing angle, we need to subtract 62 and 50 from 180. So 180 minus 50 minus 62 is going to be equal to 68 degrees. So angle K is 68 degrees. So the smallest side is going to be across from the smallest angle, which is angle L. So KM is the smallest side. And the next smallest angle is going to be angle M, so KL is the next smallest side, or the one in the middle, and since angle K is the largest angle, then ML is going to be the longest side. Okay. Theorem 5.11 speaks to triangle inequalities. It says the sum of any two sides of a triangle must be larger than the third side. Look at the following possible triangles. In the first example, one side is 2 centimeters, one side is 3 centimeters, and one side is 6 centimeters. If you were to stack these two sides onto this line, the first one, this one would come to about here, this one would come to about here. These would not even complete the line. So when 2 plus 3 is not greater than 6, then it doesn't create a triangle. In example 2, if we stack the first one on here, then the second one is going to come to here, and it reaches exactly to 4 because 2 plus 2 is 4, which creates a line, but it doesn't give us any space for a triangle. So this one also will not work. On the other hand, this last example, if we put the 4 centimeters here, and then 3 more centimeters is going to come out here. So that gives us some overlapping space, which means that we could make a triangle from this one. So this one is going to work. If we go back and look, 2 plus 3 is not greater than 6. 2 plus 2 is not greater than 4. And 3 plus 4 is greater than 5. So getting back to the two examples, the two sets of sides that we have here, if we add the two smallest sides, 18 plus 19, we get 37. And 37 is not greater than 40, so this set is not going to create a triangle. Set 2, if we add 33 and 37, and check to see if it's greater than 66, 33 plus 37 is 70, which is greater than 66, and so these three lines, or these three sides, would form a triangle. Excuse me. Okay, let's dig just a little bit deeper. Given this triangle at the bottom of your notes on the left bottom side here, what would be the possible lengths of the third side? Okay, so we are going to use theorem 511 to try and figure this out. If this side is the smallest side, and this is not drawn according to scale, if this is the smallest side, then that means that x plus 11 must be greater than 16. So let's solve to see what x would have to be. If we subtract 11 from both sides, then x has to be greater than 5. Okay, if x is the largest side, then 11 plus 16 has to be greater than x, or 27 has to be greater than x. So we could also say that x is less than 27. So this means between this inequality and this inequality that we want 5 to be, or x to be greater than 5 and less than 27, which means that x is between 5 and 27. So we would write that like this, where x is greater than 5 and x is less than 27. This is the inequality that describes what length x has to be in order to make a triangle. Okay, that's it. See you tomorrow.